Welcome to lesson number 2, solving a system of quadratic equations. Okay, so the last lesson we looked at, we were looking at linear quadratic equations. So we were looking at two lines which would take the form y equals mx plus b, and then the other line will take the form y equals ax squared plus bx plus c. And then we were looking at the 2 points of intersection, or 1 point or no points of intersection, based on how many solutions each of those equations had. Now, when we're looking at the quadratic-quadratic system of equations, both of the equations in our line are going to be in the form of y equals ax squared plus bx plus c. So for this first example, let's consider these two systems of equations. So y equals 6x squared plus 7x minus 4, and y is equal to 2x squared minus x plus 1. So in dealing with both of these equations, one way we can solve this is to solve it algebraically, and the other way is to solve it graphically. So let's first solve it algebraically. Now, just like we did last time, we are going to set these equations. Since both of them are equal to y, we could also say that y is equal to y, or that each of these are equal to each other. So 6x squared plus 7x minus 4 is equal to 2x squared minus x plus 1. And so we're going to tackle this the same way we tackled the other ones, and that's simply by balancing out our equation. So I'm going to bring this 2x to the other side, which will leave me with 4x squared. I'll bring this x to the other side, so I'll add it to the other side, which will leave me with 8x. And then I'll subtract this one from this side and from this side, which will leave me with negative 5. And that is equal to 0. Now what we need to do is, remember, if we have a variable in front of my x squared, so if it's ax squared, then we need to factor this by, first of all, decomposing it, and then filling in everything else. So if I were to decompose this, 4x squared, then I'm looking for, we got to kind of solve the riddle here, right? I'm looking for a number that is going to, it's going to give me a product of 4 times negative 5, which would be negative 20. So a product of negative 20, but a sum of positive 8. And so negative 20 and positive 8, if I choose the numbers negative 2 and 10, those will probably be my factors to decompose this. So I'm going to put in negative 2x, and 10x minus 5 is equal to 0. Now remember, after we've decomposed this, now the next thing I need to do is I need to separate this by factoring both sides of this equation. So with 4x squared minus 2x, I can take out the 2x, which will leave me with 2x minus 1. And over here, I could also take out, well, I could take out 5 in both cases, which would leave me with 5 times 2x minus 1 is equal to 0. And when I bring that together, I'm left with 2x minus 1 times 2x plus 5, and that is equal to 0. Which also gives me my zeros, or my x's, which is x is equal to positive 1/2 here, and in this case, and x is equal to negative 5/2. And now remember, you can solve each of these just by setting both of these factors equal to 0. Okay? And so these give me my x values, but they don't give me my y values. And in order to find my y values, I'll just plug them into one of my equations. Okay? So let's first look at when x is equal to 1/2. And we'll plug that back into our equation of 2x squared. Y equals 2x squared. And it doesn't matter, you can plug into either one. But 2x squared minus x plus 1. Y is equal to 2 times 1/2 squared minus 1/2 plus 1. So you can solve this, but you're going to need an answer of 1. And then when x is equal to negative 5/2, we'll plug it into the same equation. Y equals 2 times negative 5/2 squared minus negative 5/2 plus 1, and you're getting an answer of 16. So our solution to this set of equations is going to be x is equal to 1/2 and -5/2. And then x is equal to -5/2 and y is equal to 16. Okay, so the next thing we want to do is sketch the equations on the grid and using a graphing technique to determine the solution to the system. And then we just want to stay in an appropriate window. So basically all we want to do is plug this into our graphing calculator. Okay, so 6x squared plus 7x minus 4 and 2x squared minus x plus 1. All right, and we're looking for our points of intersection. So let's change our window settings here. Let's go with -5, 5, and 1, and 1, and -10, 30, and let's go with 5. All right, so when I graph this, I'm just gonna kind of try to graph it freehand here. It looks like my other graph is going somewhere like this. So my points of intersection I'm going to look at are going to be here and here. Okay, so the window settings I chose here were x is -5, and these are going to be something you want to play around with based on the graph you're using. But these are the window settings that I chose to use. And they want us to use a graphing technique, so let's use our intersection technique. So what I'm doing here is I'm looking at where these intersect. And so this one intersected at 0.5 and 1. Sorry, that was y equals. Oh, sorry, I messed up my solution earlier. So my solution here was x was 1/2 and y is equal to 1. And then I had x was -5/2 and y is equal to 16. So for this first solution, I have x is equal to 1/2 and y is equal to 1. And if we look at our systems of equations, then we would see that they do intersect at 2 points, right? So here, this was the first point at 1/2 and 1, and our second point is going to be here, and that should be at -5/2 and 16. But let's take a look. So my first curve, I'll just choose right here, and then my second curve is there, and let's see where they intersect. At -2.5 and 16, and y is equal to 16. 2.5 is this -2.5 is the same as -5/2. So we are at x is equal to -5/2 or 2.5, and y is equal to 16. So the next thing you need to do is just verify the solutions for both equations. And remember, when you are verifying, remember that you're plugging in both of these values of x and y into both values, or into both original equations. So essentially you're going to be inputting it back into two equations 4 times. Okay?